All right, so here we want to write a composite function of two simpler functions. So we're going to have two functions. So usually what I want to look at is kind of like the inside function and the outside function. Now the inside function is going to be what I'm going to plug in. So I'm going to say maybe in this case, I'm going to use that piece as my inside function. And maybe over here, maybe I'm going to say, well, let's do this piece as my inside function. So if I do that, then let's let u equal what I just said, minus 2x. Well, then what is f of u? Well, that's going to be 50 e to the u. And so if I plug it back together, if I plug u back into here, then I'm going to get 50e to the negative 2x. And so that's kind of writing a function as a composite of two simpler functions. One function is this one, the other function is this one. Now, I could have also said, this was, g of x, and then I could have had this and done things like that. But I'm just going to kind of keep it simple to kind of show you that, I'm just going to say this is u, plug it into here. Same thing here. I'm going to say, well, let's let u equal this, and that's going to be 1 plus x cubed. So kind of like what I said, take that inside function. And then f of u is going to be what? Well, it's going to be the cubed root of, and it's just going to be u. So then I can plug that in here, and when I do, I get the same thing back out. And so that's kind of how, you can write composite functions backwards out of there. All right. So let's go to our next rule, which is the general power rule. And so this is called theorem 1 in 10.4. So if u of x is a differentiable function, n is any real number, and y is equal to f of x, and that's equal to u of x to the n power, then the derivative of f of x or y prime is equal to, and we're going to take n down front, and it's going to be n times, and then it's going to be what's inside of here to the n minus 1. So it's kind of like the power rule. But now we have a function inside here. And so this is kind of the inside function. And now what we have to do is we have to work with that. And so we have to take the derivative of that inside function. And so then we'll multiply all that by that inside function derivative. So this would be kind of like, if we did the normal power rule, we have maybe x to the n, and then the derivative would give us nx to the n minus 1. Well, this is nice that we just had x. But what if instead we had something that was actually a function, a big thing, and then what we'd have to do is we'd have to take the derivative of that times this whole piece here. So we'd have to multiply it by that. Now the derivative of x is just going to be 1, and so this is really times 1 here based on this here, but this could be something much more complex, and then we'd have to take that derivative. And so different simplified notations would be y prime equals n u to the n minus 1 times u prime, or d dx of u to the n is equal to n u into the minus 1 du dx. And here u is equal to ux, okay? And so again, it's that function inside here. All right, so let's find these indicated derivatives. And so we've got a few to work on here. And the first one is we want to find h prime. So let's maybe do it over here. So for a, h prime of x is equal to what? All right, so again, we have an inside function. And if we let that just be our u, what we could do is we could say, okay, what we're going to do is we're going to say, well, it's going to be n, because we're taking our power rule, n to the minus 1 of u, and then take the derivative of that. And so we're going to have, using our power rule, bring that down in front, we'll have 3 times 5x plus 2, 3 minus 1, which will be 2. And now we have to multiply that by the derivative of that inside function. Well, that in this case is pretty simple. That's just 5. And so if we multiply that out, that's going to be a 15 times 5x plus 2 squared. And that would be our h prime of x. What about b? All right, so here we're taking d dt, and so we have this here function. Yeah. Oops, I'm on the wrong one here. B is here. So I was like, well, that looks funny. Okay, so this one we have again a function here, and we have just a power rule. So it's going to be like that. So we have, in this case, y prime is equal to what? Well, we'll bring down that 5. So we'll have 5 times x to the 4th minus 5, and 5 minus 1 is going to give us 4. Now we have to take the derivative of this inside function. So that would be a 4x to the 3rd. Okay. And so now we can simplify that, take 5 times 4, that's going to give us 20x to the 3rd, and then we have x to the 4th minus 5, and that's all to the power 4. All right, so that would be how I would do B. Now we can do C. Maybe we can move, maybe C, we can move over to here. Then maybe we could do D over here. I don't know. And so we're going to take D dt, and it's going to be what? Well, I'm going to rewrite this one. I'm going to say, well, this would be a quotient, so we'd have to do a quotient rule. But we could also do a thing where we say, well, this is really a t squared plus 4, and that's to the minus 2. Because now we're going to kind of use that power rule more like what we're doing in this section. I could bring that down front and do this is my inside piece and go from there. So d dt, I'm going to say is equal to what? Well, I'm going to bring out minus 2 down. I'll have a t squared plus 4 to the minus 3, because if we subtract 1 from here, it's going to be minus 3 times the derivative of the inside function. Well, that's going to be a what? A 2t. So now what do I have? Well, it's a minus 2 times 2, so it's going to be a minus 4t. And if I go ahead and make that positive again, that's going to be a t squared plus 4 to the positive 3. And so then that would be my derivative of this original function. Again, to make it so we could use the general power rule, we had to make it into the form where we could do a power rule. And that's going to be the same case here. We're going to have to make this one into something that looks more like the power rule. So if we say that's 4 minus w to the 1/2, that's going to work a lot better. So then d is going to be what? Well, now we have g prime of w is equal to what? Well, now we take, and we have our inner side piece, we'll take our half down. That's going to be a 4 minus w to the minus 1/2, because half minus 1 is minus 1/2. Now the derivative of this is just going to be what? A minus 1. Now we multiply this out. Well, it looks like on the top we just have a minus 1. On the bottom we have that 2. That's really the square root on the bottom, so square root of 4 minus w. And then that would be our derivative of our original square root of 4 minus w. Okay, so first we put it into this so we could use our general power rule, and then after that we worked it out and then simplified it back down to having positive powers, which put it down here, and that gave us that. All right, so let's stop there and we'll come back for more.